Thanks, Rosina. I also want to thank Kathy. You did really an amazing job herding cats. When Emily talked about the review process, she sort of just glossed over it a bit. But not only did we have each of the individual chapters reviewed, but they actually had to say the same thing across chapters. So the water chapter had to say the same thing about water as we were saying in the Midwest chapter, and it was very, very complicated. And for those of you that make a living out of publishing papers in peer-reviewed journals, you have to satisfy 2 or 3 reviewers and an editor. We had maybe 400 comments to respond to just in our chapter, and we had to respond to every single one of them. So it was an enormous effort in the review process. And all that for 8 pages, which is all we had space for in our chapter. So I do want to point you back to the technical inputs that Emily had mentioned. Glisa produced an entire book of input to the assessment. It's very rich in details. And so we only had 8 pages, but it's based on a lot of that really great information. So this is the authors of the Midwest report, a great group across a bunch of different disciplines and sectors. And we had a great time doing it. And this citation at the bottom if you wanted to see any more details than what I'm going to present here. I'm only going to show you 2 climate graphs because you're seeing a lot of it, but I wanted to focus on these 2, one on temperature, one on precipitation, focused in the Midwest. And so in the Midwest, average temperature is increasing like it is everywhere else. But it's interesting to look at the number of days above 95 degrees, the increase looking at 15, 20, 25 days a year increase by mid-century. And then the bottom left-hand corner, the frost-free season. And I'm going to touch on this again when I talk about the agricultural program. Again, a very, very dramatic increase in that season. And then in precipitation, we've also heard quite a bit now about the average precipitation increasing, the heavy precipitation increasing in different ways even within the region. And I'll come back to this at the end. If you look at sort of northern and northwestern Ohio, within this region, you're getting particularly large increases in precipitations and have had that in the past. So I will touch on each of these. And what I'm going to do is I'm going to paraphrase the key messages in each of the, several of the key messages in our chapter, and then show you some examples of what we're talking about. So impacts to agriculture in the Midwest region, in the next few decades, there actually will be longer growing seasons, and increasing CO2 could increase some of the yields in agriculture. But there could be very important offsets by extreme weather, and I'll tell you one example of those in a second. But in the longer term, the stresses that are associated with climate change are expected to decrease agricultural productivity overall. And this is one of the graphs showing in the Midwest, corn, soybean is sort of the dominant feature in our region, and both corn and soybean will be showing decreased yields as temperature increases. And you saw the projections for this region of 4 or 5 degree increases, and you can see the dramatic decreases in yields in both of those. The growing season in this region has been increasing during this time period. It's lengthened by about 1 or 2 weeks in the last few decades. And it's increased mostly because the last frost in the winter has started coming earlier and earlier. And it's projected to get even longer. So by the end of the century, it may be 1 to 2 months longer growing season in this region. But in this transition period, we really have to worry about this because what's happening is it's warming up sooner. And for example, the apples and the cherry trees, you're getting blossoms early, and we're still getting these cold outbreaks afterwards, and it's actually killing off off those new buds. And in 2012, $92 million loss in the cherry tart industry alone because of this phenomenon. And we're likely to see this happening during the transition period. So the fruit tree industry in this region is going to continue to be hurt. Forest impacts. So the forest composition is expected to change as the rising temperatures are going to move the tree habitats northward and other habitats as well. And the role of the region's forest as a net absorber of carbon is potentially at risk, or no longer be such a strong absorber. This is a map showing the shifts in the composition, the projected shifts in composition in those species. The left hand shows the current, and I've sort of highlighted the oak, hickory, and the maple beech birch complexes for Michigan. And you can see that into the future, particularly under higher emissions, a very dramatic shift northward of those species. So you're getting mostly dominated by oak, hickory, and almost completely loss of the maple beech and birch complex. And these impacts on biodiversity, in addition to these shifts, are really important because the species will have to be migrating north, those that are temperature dependent. But in the Midwest, it's particularly tricky. In other places where you have lots of mountains, you can actually just migrate a few hundred or maybe 1,000 feet up a mountainside to get to the right temperature. Here you have to migrate thousands or hundreds of miles northward because it's such a flat terrain to get to the temperatures that you're looking at. And we've got things in the way, like agriculture in the Great Lakes. It may be difficult for species to migrate to habitats that they want and they need northward. Public health risks. Maria already talked about these. I want to emphasize a couple, particularly for our region. If you looked at the historical heat waves and the impacts of heat waves in this region, in Chicago, over the last 63 years, we've increased one increased death per year during this time period, and Detroit, 2 per year. And in the projections into the future climate, they're looking at an example that's in our report is that there could be as much as 166 to a couple thousand increased deaths in Chicago alone due to the extreme heat waves on into the future. And flooding and stormwater, there's also talk about this already from both Marie and Kathy. So these strong storms creating these flooding events have tremendous impacts potential impacts on human health. The impacts of the combined sewer overflows and others. And the upper right-hand corner, I have to point this out. This is actually looking out an office window in Grand Rapids during one of the recent storms. You don't want to look out and see a duck floating by. Whether it's a health impact or not, you don't want to see that. And these storms have other influences that I'll get to in a second when we're talking a bit more about Great Lakes. So we're projecting that there'll be changes in the range and distribution of fish species within the Great Lakes. Increase in invasive species, increases in these harmful algal blooms, declined beach health caused by the combined storm sewer overflows. Combined storm sewers are very prevalent in the Midwest region, and there are particular problems associated with that. Less ice on the lakes could actually lengthen the navigation season. So I'll give you a couple examples of this. The Great Lakes are warming. There's no question about that. The ice cover has decreased over 70% since 1973. Interesting phenomenon with the physics of lakes, that Lake Superior is actually warming twice as fast as the air. And that's actually exaggerating the impact of no ice there. Lake Superior could have no open ice lake within the next open lake ice within the next 30 years. So an ice-free lake can allow you to have a longer shipping season, which could be very positive for the region. But while there's still some controversy about whether or not this climate change is going to lower the lake levels or increase the lake levels in some case, if in fact it does lead to lower lake levels, then there's dramatic economic impacts because every inch of lake level that's lost, you're losing $10,000 to $30,000 per transit in the ships because they just carry less cargo. So we have this sort of dual thing that we may actually be getting a longer shipping season, but we may have to be carrying less cargo when we do that. And then I want to end with this conspiring changes on water quality, an example in the Great Lakes. So these stronger storms are forcing much more runoff into the systems, greater nutrient loads into the systems. And at the same time, we're getting warmer lakes, longer growing seasons, which are leading to these larger or more frequent events with algal blooms and dead zones. And the one that Marie showed here, again, this was Lake Erie, and in 2011, the largest storms in the region, flowing particularly onto the northwestern Ohio and southern Michigan, loading phosphorus into the lake, causing this massive toxic bloom. And in a paper that we published, a large group of us in Proceedings of the National Academy of Science decomposed this event, looking at both sort of the current climate signal, the future climate signals, and the effects relationship between that precipitation, what happens on the land, what happens in the lake, and we are suggesting that this is the future for Lake Erie unless we do something different on the land to keep the phosphorus from going into the lake. So the impacts in the Midwest are dramatic in many ways. Both temperature and precipitation will impact both the engineered systems as well as the natural environment. So what do we do? Rosina was involved in this report that talks about avoiding the unmanageable and managing the unavoidable. So clearly reducing emissions, mitigation is the hallmark, the thing we have to actually really focus on very strongly, but we need to prepare for a change because the changes are already built into the system. So the question is, how well are we in fact preparing for this? And hopefully over the next day or two we'll find out how this region is preparing. Thank you.
overnight low temperatures have tended, in most parts of the region, to increase faster than those annual averages.